This $50 device creates freezing cold air from nothing but compressed air. It uses no refrigerant, no compressor, no electricity, and no moving parts. Yet it produces air as cold as -50 degrees Fahrenheit from one end and scorching hot air from the other, using nothing but a hollow metal tube and pressurized air. Despite being proven for nearly 100 years, it does not appear in a single American home cooling catalog. It's called a VORTEX tube. By the end, you'll know what it is, how it works, and where it fits in your life. Let's dive in. Right now, the average American household spends roughly $2,000 a year on air conditioning alone. A central air conditioning system costs between $5,000 and $12,000 installed, and the refrigerant inside it is quietly being phased out by federal regulation every few years. R-22 was banned. R-410A is being phased out by 2036. Every phase-out means new equipment, new certifications, and new bills for you. And here is the part nobody puts in the sales brochure. Your compressor, the single most expensive part of any air conditioning unit, has a working life of 10 to 15 years. When it fails, you replace the entire system. That is not cooling independence. That is a subscription plan wrapped in aluminum housing. The Department of Energy's own data confirms it. Residential cooling now accounts for over 12% of total U.S. electricity consumption. You are paying more than ever for a system built to fail on a schedule. But there is a device that produces industrial-grade cooling with zero refrigerant, zero moving parts, and zero degradation. And it has been sitting in engineering textbooks since 1928. The real question is not whether the VORTEX tube works. The physics were settled by 1946. The real question is what happens when a $50 piece of pipe outperforms the compressor in your window unit. And that is where this technology stops being a curiosity and starts being a threat to a $180 billion HVAC industry. A VORTEX tube is a hollow metal cylinder with air entering from the side. That term sounds technical, but the principle is one you already know. If you have ever watched water spiral down a drain, you have seen the same physics at work. Compressed air enters the tube at an angle, forcing it to spin at speeds up to 1 million rotations per minute. That is not a typo. The air spirals along the inner wall of the tube, and here is where the impossible starts. The outer layer of the spinning air becomes hot, up to 260 degrees Fahrenheit. The inner core becomes cold, down to -50 degrees Fahrenheit. Two streams of air, one freezing, one burning, from a single stream of ordinary compressed air. Physicists call this the Rankine-Hilsch effect. For 60 years, thermodynamicists argued about why it works. Classical thermodynamics could not fully explain it. The energy separation appeared to violate expectations, and yet the device kept producing measurable results in every laboratory that tested it. It was not until modern computational fluid dynamics that engineers confirmed the mechanism. The angular velocity gradient forces energy to migrate outward, cold to the center, heat to the walls. Nature does the work. Your compressor does nothing. A commercial VORTEX tube produces cold air at 2 to 4 cubic feet per minute per cell. That is not enough to cool a whole house, but wire 4 of them into a manifold, and you have a spot cooler capable of dropping a 200 square foot room by 20 to 30 degrees Fahrenheit. That is enough to cool a workshop. That is enough to keep a server rack from overheating. That is enough to cool a small bedroom at night. And none of it requires a single refrigerant regulated by EPA. In 1928, A French physics student named Georges-Joseph Rank was working on a VORTEX-type pump at his university lab in Paris. He noticed something impossible. The air coming out of one end of his prototype was cold. The air from the other end was hot. He had not designed it that way. Nature had. Rank filed his French patent in 1932 and his US patent in 1934. He presented his findings to the French Physics Society in 1933. The response was silence. Established physicists refused to believe a hollow tube could separate heat from a single gas stream. Rank, humiliated, abandoned the invention. For 14 years, the VORTEX tube sat forgotten in a French patent office. In 1946, a German physicist named Rudolf Hilsch rediscovered Ranke's paper while researching low-temperature refrigeration in post-war Germany. Hilsch built his own version, measured the temperature separation precisely, and published his results in a peer-reviewed journal. The device was renamed the Rank-Hilsch VORTEX tube. Rank died in 1973, largely unrecognized in his own country. Hilsch's paper is now cited in over 400 published studies. If you think this technology never left the laboratory, you are off by decades. NASA has used VORTEX tubes to cool spacesuits during extravehicular activity since the 1960s. The US military uses them to cool tank crews in desert operations, where temperatures exceed 130 degrees Fahrenheit. CNC machine shops across America use VORTEX tubes to cool cutting tools without oil-based coolants. The Department of Defense specifies VORTEX tubes in radar and electronics enclosures where refrigerant leaks would be catastrophic. In a 2019 peer-reviewed study published in Applied Thermal Engineering, researchers measured a temperature drop of 71 degrees Celsius, that is 128 degrees Fahrenheit, from a single commercial VORTEX tube running on standard shop air pressure. Companies like Exair, VORTEX, and NextFlow sell industrial units used in over 60 countries. A commercial-grade VORTEX tube from these manufacturers costs between $150 and $400. A do-it-yourself adapted version, built from standard hardware store components, costs under $50. So if the physics were confirmed in 1946 and NASA has trusted this technology for 60 years, why is it not on a single residential cooling product list? Because the residential HVAC industry was never designed to accommodate something you can build for $50. Every major HVAC manufacturer is built around one product category, the vapor compression cycle. Compressors, refrigerants, service contracts, refrigerant recovery, EPA certifications, licensed technicians. Every dollar in that industry passes through equipment that someone owns, services, and invoices for. A VORTEX tube generates no invoice. It requires no refrigerant. It creates no recurring revenue stream. From the perspective of the HVAC business model, the VORTEX tube is not a competitor. It is a non-entity. This is not a ban. It is something more effective than a ban. It is structural invisibility. Here is what makes the VORTEX tube practical for real-world use. The device needs three simple things. First, a source of compressed air, meaning any standard workshop compressor running at 80 to 100 pounds per square inch. Most garages, shops, and off-grid setups already have one. Second, a small metal tube assembly, brass or steel, available through industrial suppliers or built from off-the-shelf pipe fittings. Third, an outlet configuration that separates the cold stream from the hot stream. The colder you want the output, the higher the pressure you feed in. The greater the ratio of cold fraction bleed, the colder the temperature, but the lower the volume. Adjust the balance and you tune the tube for your space. A single commercial unit will cool a workstation to 20 or 30 degrees below ambient. A manifold of 4 units will condition a small room. And unlike compressor-based air conditioning, the VORTEX tube has no seals to fail, no oil to change, no refrigerant to leak. As long as your compressor keeps producing pressurized air, the tube keeps producing cold. There are honest limits. A VORTEX tube needs continuous compressed air, meaning you need a compressor or an air tank. It is not silent. It is loud, like any pneumatic tool, and it will not cool an entire house. But for spot cooling a workshop, a server enclosure, or a garage, it delivers freezing air from a $50 piece of pipe with no refrigerant to leak, no compressor to burn out, and no moving parts to service. If discovering the lost science of home cooling matters to you, subscribing is the simplest way to keep this knowledge alive. If you had a shop compressor and $50 to spend, would you use a VORTEX tube for spot cooling? Drop it in the comments.